how are you? In this lecture, we would like to talk about rational expressions. I want to define what a rational expression is and how you simplify rational expressions. So you'll see here, a rational expression are algebraic expressions in fraction form having a variable in the denominator. You'll see 4 different examples here. Notice what's common to all of them is every one of them have a variable in the denominator. The denominator could be something simple, just like an x only. None of these just have an x. This one at the end has an x squared. Or it could be a trinomial like this one, x squared minus 3x minus 10. But they all are in fraction form, which is what rational means in math. It comes from the word ratio. We're dealing with a fraction that has a variable in the denominator, which means that there will be places that these rational expressions are undefined. There will be numbers that you're not allowed to plug in because you get a 0 in the denominator. So let's look at our first example. A, determine the values for which the rational expression is undefined. Now when we look at this first example, number 1a, 5 over x, what if x were to equal 0? Well, what would happen? Well, that would give us 5 over 0, which means the function or the expression is undefined. We can't divide by 0. We all know that, right? So the place or the value for which the rational expression is undefined in the first problem is x equals 0. So when you look at the second problem, x over x minus 2 or x divided by x minus 2, what would make that expression undefined? Well, if the denominator were equal to 0, it would be undefined, correct? So if I set my denominator equal to 0 and solve, that would give me x equals 2. Now notice, if I plug in 2, that would give me 2 over 2 minus 2, which is 2 over 0, and notice, that is an undefined fraction. Therefore, x equals 2 is the value for which this expression is undefined. And if I look at my third example down here, x plus 4 over x squared minus 3x minus 10. Now the x plus 4 is not an issue in this question. What matters is what would make this denominator equal to 0. So what you do is you set the denominator, that is the rule, every time you set the denominator equal to 0 and you solve. Now, this is not linear. Notice the last problem is a linear equation. We have x to the first power, so all we did was add 2 to the both sides. But x squared minus 3x minus 10 is a trinomial. Remember, we spent a lot of time learning how to factor trinomials in the last section and solve this equation. So when I factor, I'm trying to find numbers that multiply to be negative 10 and add to be negative 3. And those two numbers are negative 5 and positive 2. So I set x minus 5 equal to 0, and I set x plus 2 equal to 0. That gives me 2 answers. X equals 5 and x equals negative 2 would make this expression undefined. So most people forget how to do these problems. So remember, when you read determine the values for which the rational expression is undefined, you set the denominator equal to 0 and solve for x. Sometimes solving the equation is real simple. You just move a number to the other side and then divide. Sometimes you're going to have to factor, which is what you learned in the last chapter. So let's continue trying this. Determine the values for which the rational expression is undefined. So once again, when you read that, you know you're supposed to set the denominator equal to 0 and solve for the variable. So our variable b, I need to get it isolated. I'm going to divide both sides by 4 to get b equal to 0. So imagine if I plug 0 into this expression, that would give me 3 times a over 4 times 0, which would be 3a over 0, which is definitely undefined. I'm never allowed to divide by 0. So my next problem I've got 2x minus 1 divided by x squared minus 9. So once again, the denominator is not allowed to be 0. So what I want to do is find out what x values would make it 0. Now this, you'll recognize, is first of all, it's a square. So we're going to have to factor. This is a difference of squares. So remember to factor a difference of squares. You take the square root of the first term, that goes in the first position. You take the square root of the second term, that goes in the second position of our two binomials, and inside you have a sum and a difference. Now I set each of these factors separately equal to 0. I subtract 3 over to get negative 3. I add 3 over to get positive 3, and there are two different locations that our x values are equal to 0. If you were to type this into the system, that would be your answer, negative 3 and 3. In the last example, I set the denominator, x squared plus 16, equal to 0. I attempt to factor. It will not factor. So at this point, I don't really have a technique to solve this, but I do want to show you something. I want you to think about this. Is there a number that we could plug in for x that we add to 16 to make it 0? And if you think about that, the x squared have to be negative 16, right? Well, negative 16 plus 16 adds to be 0, but how do I make x squared equal to negative 16? Well, I can't. Anytime you square a number, whether it's negative or positive, it turns positive. So there is no solution to this equation, which means there are nowhere is it undefined. This expression is defined everywhere. You could substitute any value for x and you would never get a 0 in the denominator. Now onto a new type of problem. We're supposed to evaluate the expression y minus 3 over 2y plus 1 for each of the given values. And the first value is y equals negative 2. So what I'm going to do is substitute. I'm going to remove the y and use parentheses and replace it with negative 2. So I have negative 2 subtract 3. In the denominator I have 2 times negative 2 plus 1. And now I use order of operations to simplify. Negative 2 minus 3. Some of you are still using the properties of exponents. The properties of integers. And this is subtraction. Change it to addition. Change the sign of the next number. So that would give you a negative 5 in the numerator. Divided by, in the denominator, I multiply first. So it's negative 4 plus 1. And then I add negative 4 plus 1 to get negative 3. And then a negative divided by a negative is a positive. And we keep the 5/3. As long as your fraction is in lowest terms, that's the type of answer we're looking for. All right, let's try it again. But this time we're going to substitute 1. So I have 1 minus 3 divided by 2 times 1 plus 1. Now we all know 1 subtract 3 is negative 2, or once again you could do the keep, change, change. So I keep the 1, change subtraction to addition, I change the sign of the next number. That's also negative 2 because you subtract the numbers and keep the sign of the heavier number. Alright, in the denominator, 2 times 1, multiplication comes before addition, and then I add to get 3, and a negative divided by a positive is overall a negative, so this is an acceptable answer, or negative 2 over 3 is an acceptable answer. And then the last problem, we're going to let y equals 0. So I have 0 subtract 3 divided by 2 times 0 plus 1. 0 minus 3 is negative 3. 2 times 0 is 0 plus 1 is 1. That's negative 3 divided by 1. And whenever you divide by 1, you just get the number back. Negative 3 divided by 1 is negative 3. So completely simplified, that answer is negative 3. Here are again some substitution problems. I'm supposed to substitute y equals 0. So I have removing every single x and replacing this with 0. So I have 0 squared minus 5 times 0, subtract 2. Divided by 0 squared minus 1. Then I perform order of operations. I'm looking at the numerator completely separate than the denominator. In the numerator, I need to do exponents first. So 0 times 0 is 0. Minus, I can go ahead and multiply. 5 times 0 is 0, subtract 2. In the denominator, 0 squared, or 0 times 0 is 0, subtract 1. Back to the numerator, 0 minus 0 is 0, minus 2 is negative 2, divided by negative 1, which gives me a positive 2 is my result. This time I'm going to do the same expression, but I'm going to substitute negative 1. So negative 1 squared minus 5 times negative 1, subtract 2, divided by negative 1 squared minus 1. Those parentheses are necessary to denote that you're squaring the negative number here, to denote multiplication here. Be very careful. They're required. Now I'm doing exponents. Negative 1 squared is negative 1 times negative 1, which is positive 1. Here I can imagine this as a negative 5 times a negative 1, which is going to give me a plus 5. Or you can ignore this subtraction and say minus 5 times negative 1, which is a negative 5, but to be minus a negative 5, which is still plus 5. So if you're thinking about that in a different way, we're still going to be in the same place at the end. Negative 1 squared is negative 1 times negative 1 is 1 minus 1. Now watch this. 1 plus 5 is 6 minus 2 is 4, divided by 0. What do we know? Undefined. Turns out we were not allowed to plug negative 1 into this expression, and that happens. And so this is undefined. If you're doing this on the computer, that's the answer. So it's like the empty set. Now I substitute in 3. So I have 3 squared minus 5 times 3 minus 2 divided by 3 squared minus 1. Completely simplify the numerator and the denominator separately. 3 squared, we know is 3 times 3 is 9. Negative 5 times 3 is minus 15. Minus 2 divided by denominator. 3 squared is 9 minus 1. 9 subtract 15 is negative 6. Subtract 2 is negative 8. Over 9 minus 1 is positive 8. Negative 8 divided by positive 8 is a negative 1. Now I want to spend a little bit of time talking about simplifying rational expressions. A rational expression is simplified if there are no common factors. So if we look at the examples in red, 3 over x is completely simplified because 3 and x don't have any common factors, whereas 3x over x squared is not, because of this x and this x squared. There are common factors there, and they must be canceled out to be completely simplified. Okay? Here, simplified x plus 1 over x, that is simplified. Now, careful. You cannot cancel this x and this x. I know you want to, but you can only cancel common factors. X and 1, they are sums. Okay? That's a sum right there. You're adding x plus 1, so you can't cancel part of a sum or part of a difference. It has to be multiplication only, like above here. In the red example, those can be canceled because they're being multiplied on top and bottom, whereas this x and this x are not factors, okay? So you cannot cancel these. Now, on the other hand, when I look at the second blue example, I can cancel this x plus 1 with this x plus 1. Because that's an entire factor there that I'm canceling. If this were an x plus 1 in the bottom, I could do that. But you can't cancel part of a sum or addition. The only x plus 1 you can cancel is with another x plus 1. Now in green at the bottom, a, b, and c, no common factors there. But there are many common factors over here. So for example, this a squared and this a, I can cancel one of these a's with that a. The b to the third and the b squared, I can cancel 2 of these up here. That's going to leave b to the first, and those are completely gone. And then the c squared and the c to the third, I can cancel 2 of these down here. That's going to make that c to the first, and that's gone. So my final answer here would be b divided by c, and that's it. And we'll practice those. Now, we've learned how to do this already. You have already test 1 in this class. You simplified these expressions. We're going to do more of that and add to it. So here we are. We're at the simplify problems, and this is really what the meat of this section is all about. And these are two problems that you should recognize, not specific, but you've done this before. So what I'm doing is first I'm looking at 15 and 20. What do 15 and 20 have in common? Well, they both divide by 5. So I can say 15 divided by 5 is 3, and 20 divided by 5 is 4. And then we can look at the x squared and the x to the third. Remember, the rule is you subtract the exponent and leave it where the larger one is. So this x squared is going to cancel with two of those. It's going to make that an x to the first. And this y cancels that y completely. Now, I know it's hard to see what we have, but in the numerator there's only a 3 remaining. And the denominator, it is a 4x. But again, these are problems that you know how to do. You can go back and look at a previous section about dividing monomials if you need to. All right, let's look at the next example. So at 12 and 36, well, they both divide by 12. So 12 divided by 12 is 1. 36 divided by 12 is 3. When I look at my x's, I subtract there, and it may just be easier to come down. So I have a 1 and a 3. I have x to the fourth and x to the third. If I subtract 4 minus 3, I get x to the first, but I leave it where the larger number is. The 4 was bigger than the 3, so I have my 1's remaining on the bottom. Same thing with the y's. The 4 is bigger than the 2, so I subtract 4 minus 2 is 2, but since the bigger one's in the denominator, the answer remains in the denominator. And z to the third, remember there's a 1 right there. 3 minus 1 is 2. Again, the 3 was bigger, so z squared in the denominator. So final answer, if I make that look a little bit neater, is 3x y squared z squared. Final answer there. I do want to spend a second talking about what you can do versus what you cannot do, because this is one of the largest mistakes that students make. Simplifying rational expressions. Notice the 5 and the 6 here, those are factors. Now, what a factor is something being multiplied. So the 5 is being multiplied by the 6 and vice versa, the 6 times the 5. So those are factors. And I have a factor of 5 in the numerator and a factor of 5 in the denominator, so those cancel to give me 6. Now, if you instead, before you cancel, if you actually multiplied, to simplify that, 5 times 6, let me do this in green so you can see it. 5 times 6 is 30. And then over 5. Now we know that is 6, right? So those match. We know that this is a correct step to take. But over here, different, there we go. Over here, the question is, can I cancel that 5 and that 5? Well, what we need to do is simplify the expression without canceling. Just do the operation. 5 plus 6 is 11 divided by 5. That doesn't simplify anymore. But had we canceled this 5 and this 5, which we cannot, we would get 6. And we know that's not right. So you are not allowed to cancel part of a sum or subtraction, like if I made up another one, like 6 minus 1 over 6. You cannot cancel those 6's. You would have to just either leave it the way it is, or in this problem you could do 6 subtract 1 is 5 over 6 and you're done. But you cannot cancel those 6's. But when it's multiplied, you can. I need for you to really understand that before moving on. Alright, so our next problem, it says to simplify, what you need to do is factor the numerator and the denominator completely if possible, and then you cancel common factors using properties of exponents. So what I cannot do is cancel this 2 and this 2, or this 6 and this 6. And the reason is because there's a big subtraction in this problem and a big subtraction down here. That, again, that would be canceling part of a sum or a difference, and you can't do it. So instead, what I'm going to do is factor. Notice in the numerator, there's a greatest common factor of 2. So I'm going to pull out that 2. Okay, so when I divide that by 2 and that by 2, it's going to give me x minus 3. But notice I still write the 2 that I'm dividing by. In the denominator, there's a 4 in common. So I'm going to divide this by 4 and this by 4. The 4 comes out, and that's going to leave me with x minus 3. Now here's what can happen. I can cancel this x minus 3 with that x minus 3 because that is a factor now, because the 2 is a factor and the x minus 3 is a factor, and the denominator, the 4, is a factor and the x minus 3 is a factor. Now think about what that leaves us. It leaves us with 2 over 4, which is also not completely simplified because they both divide by 2. So 1/2 is my final result. Let's try it again with another problem. Maybe pause it and try this yourself. But what I notice on the top is the greatest common factor of 2. I'm going to pull that out. So that means I'm dividing each of these terms by 2. It gives me x plus 1 left in parentheses. And the denominator, that right there, is a difference of squares. So again, you're going to have to know how to factor to get through this entire chapter. I cannot encourage you enough to make sure you know how to factor before you move on. So a difference of squares, remember you take the square root of the first term is x in the first spot. The square root of the second term is 1 in the second spot. One of your factors is a sum. One of your factors is a difference. Now what I notice is this x plus 1 and this x plus 1 cancel. So I have a final answer of 2 divided by x minus 1. So we have more problems that say simplify. Now again, please don't cancel this x squared and this x squared. That is totally not allowed because this is a sum and difference in the numerator. That is a trinomial. This is not factored whatsoever. Neither is the denominator. So what I have to do is factor. Now trinomials, remember, if they do factor, they look like this. Okay. The good news is these both have a leading coefficient of 1. So these are the problems that you could see, for example, on the top, it multiplies to be 6 and adds to be -5. And that would be a -3 and a -2. So my factors are x minus 3 times x minus 2. And the denominator, we're trying to find numbers that multiply to be -15 and add to be +2. That's a +5 and a -3. So I have x plus 5 times x minus 3. Now, you need to look for common factors, and we have them. Notice I have an x minus 3 and an x minus 3, which means my final answer is the x minus 2 remaining in the numerator divided by the x plus 5 in the denominator, and I am finished with that problem. Okay? So what we have here, again, I can't cancel this x squared and this x squared. I can't do anything with this 16 and this 20. That's not the way it works. Has to be factored first. The numerator is a difference of squares. X squared is a perfect square, 16 is a perfect square. Remember that those factor into a plus and a minus. The square root of x squared goes in the first position. The square root of 16, which is 4, goes in the second position. And the denominator, I'm trying to find numbers that multiply to be 20 and add to be 9, because that's a trinomial with a leading coefficient of 1, and those numbers are +4 and +5. And now I see my x plus 4s will cancel, and my final result is x minus 4 over x plus 5. The next problem, notice once again, I see 3's all over the place. I know it makes you want to cancel this 3 and this 3, or even this 3 and this 3 in the back. You can't, because that is part of a sum or a difference. That's not allowed. So you must factor. What I notice in the numerator right here is a greatest common factor. There's a 3 common to all 3 of those terms. So a 3 comes out. Remember, I'm dividing each of these by 3. So that's going to leave me with x squared minus 2x plus 1. And in the denominator, there's a 3 common. So it has a greatest common factor as well. Divide each of those by 3. I write that 3 in the front. That leaves x minus 1. But I am not finished with this problem. This is a trinomial inside with a leading coefficient of 1. So I'm trying to find numbers that multiply to be 1 and add to be -2. Those two numbers are -1 and -1. So now I'm writing this as x in the first position because the square root of x squared is x, and my two numbers -1, -1. And the denominator, I'm keeping my 3 times x minus 1. And now it's factored, which means I can cancel common factors. So I'm canceling this 3 and this 3. and this x minus 1 and this x minus 1, which leaves me a final result of x minus 1 over 1. Whenever everything is gone, that's 1. But when you have a 1 in the denominator, it is not required, so we get x minus 1. The next problem, I have a difference of squares in the numerator. So if you'll remember, don't know what happened there. I have a difference of squares in the numerator. So if you'll remember, that factors into a plus and a minus. In the denominator, I have a difference of cubes. So that's the short set of parentheses and the long set. So let's go back to the difference of squares up top. The square root of x squared goes in the first position, which is x. The square root of 1 goes in the second position, which is 1. But in the denominator, remember, you take the cube root of each. So the cube root of x to the third is x. The cube root of 1 is 1. Whatever operation, which is minus here, goes here. Then in the long set of parentheses, when you have a sum or difference of cubes, you square the first one. You multiply these two together, and you change the sign. So it's going to be plus 1x. I'm just going to write that as x. And then you square the last one and add. So I know this is always plus. And then 1 squared is 1. Now I can cancel common factors. So when I cancel this x minus 1 here, cancels with this x minus 1 here, which gives me a final result of x plus 1 in the numerator and x squared plus x plus 1 in the denominator. Notice there are no more factors at all, so I cannot cancel anything else. That problem is complete. So I have about 7 more problems for you. Just hang with me. Notice they get more and more challenging as we go along. If you look at our example M here, I have 4 terms. 1, 2, 3, 4. Now let me point out what you cannot do. This p squared and these p squared cannot cancel. And it's because this problem is not factored. You have 4 terms on top. That's addition and subtraction. You can't cancel part of addition and subtraction. So whenever you have 4 terms, y'all know that factor by grouping is something worth trying. So this is kind of scratch work that I'm doing here. I'm trying to factor p to the third minus p squared plus 2p minus 2. And factor by grouping, you group the first 2 and the last 2 together. Factor out the biggest thing you can, which is p squared out of the first one. Remember, you divide both of those by p squared. When I do that, that's going to give me p minus 1. Notice these guys have a 2 in common, so I'm dividing each of those by 2. It goes in the front. That also leaves me with p minus 1. So that means the numerator factors into p minus 1, the guy that matches, times p squared plus 2. Now I do need to look at the p squared plus 2 to see if it could possibly factor again, but it doesn't. First of all, it's a sum, so that's not going to factor anyway. When you have a binomial sum, it's not going to factor, not of squares. So let's move to the denominator. In the denominator, it's a trinomial with a leading coefficient of 1. Those are the easier ones. Try to find numbers that multiply to be -5 and add to be 4. Numbers that multiply to be -5 and add to be 4 would be a plus 5 and a minus 1. So that means this factors into p plus 5 times p minus 1. And then you look at what you've got. And I notice that I have a p minus 1 in common. So I can cancel those common factors. And then my final answer is what remains, which is p squared plus 2 divided by p plus 5. And then I circle my result. And again, don't be tempted to cancel this p squared and this p. You cannot do that. That's part of a sum or difference. I cannot express that enough. So take a look at the next problem. So notice in the numerator, I have a binomial, but I have a greatest common factor. 4 divides into both 4 and 16, and x divides into both x squared and x. So I'm going to factor out a 4x, and that's going to leave me with x minus 4. So notice what I did is I divided each of these guys by 4x. 4x here, and 4x there, and that leaves me with x minus 4. Okay, in the denominator, I notice that I have, looks like an 8 in common. Don't you see that? 8, 16, 64, 8 divides in all those, but they don't all three have an x, so I can't factor out that x. So when I do that, get my color back, I'm going to pull out that 8, and that it's going to leave me with x squared minus 2x minus 8. But I still have a trinomial in here that I could possibly factor. So when I do that, I'm trying to find if there are numbers that multiply to be negative 8 and add to be negative 2. And there are, right? A negative 4 and a positive 2 will do that. So I'm back to factoring. In the denominator, I'm going to have 8 in my two sets of parentheses with my two numbers. The square root of x squared is x. That goes in the first position. And my two numbers, minus 4 and the plus 2, go in the second position. Remember, in the numerator, I still have 4x times x minus 4. Now it's time to cancel common factors. So I have an x minus 4 and another x minus 4 that will cancel. Hey, also, this 4 and this 8 cancel to leave a 2. So let's see what we have remaining and write that as our final answer. In the numerator, I still have an x. At the denominator, I have my 2 in red here and x plus 2. And that is my final answer for question N. So the more examples you see, the better you get. So if we'll notice in the numerator here, I've got a trinomial, but there's the greatest common factor. 5 divides into every one of those. So I'm going to say 5 times, I'm dividing each by 5. Okay, so that's going to give me y squared minus 6y plus 5. That will factor more probably. And the denominator, there's a 2 greatest common factor. So I'm dividing each of these guys by 2. This also has to be written in your problem. That gives me y squared minus 25. Now here in the numerator, I still in parentheses have a trinomial, so with a leading coefficient of 1. So I'm not trying to find numbers that multiply to be 5 and add to be negative 6. That's a negative 3 and a negative 2. Oh, no, it's not. Let's try that again. How about multiply to be 5? They need to both be negative to add to be the middle number. How about a negative 5 and a negative 1? That's much better. Okay, so when I factor, I'm going to have my 5 still in the front, and that's going to be y minus 5 times y minus 1. Again, I did that quickly, so let's check. Y times y is y squared. Y times negative 1 is negative y. That's going to be a negative 5y. Those add to be negative 6y. Negative 5 times negative 1 is positive 5, so that checks. In the denominator, this is a difference of squares. So remember, a difference of squares, you have a plus and a minus. You take the square root of the first term, which is y squared, goes in the first position. The square root of the second term, 25, which is 5, goes in the second position. And then you can cancel common factors. And all I see that's common is the y minus 5. So when I write my final answer, I can write it as 5 times y minus 1 over 2 times y plus 5. Now if you wanted to, you could distribute that 5 in and that 2 in, but I don't think it's necessary. It's fine in factored form. Now if we look at our P problem over here, I have an x to the third plus 8. If you recall, that is a sum of cubes, and when you do a sum or a difference of cubes, you have a short set of parentheses and a long set of parentheses. And in the denominator, I have a difference of squares, but let's knock out the sum of cubes. The square root, the cubed root of x to the third is x. The cubed root of 8 is 2. If it's a sum, then plus goes here. Then I'm supposed to square this first term, so that's x squared. I'm supposed to multiply these two together. 2 times x is 2x, but whatever sign is here, I must change, so that's minus. The last term is always plus, no matter what your original sign is here. You square this second position, which is 4. In the denominator, that's a difference of squares, so that's the one where you have a plus and a minus. The square root of x squared goes in the first position. The The square root of 4, which is 2, goes in the second position. Then I cancel the x plus 2's because that's what's common. And my final answer is x squared minus 2x plus 4 divided by x minus 2. It's all about factoring. It really is. If you're skilled at factoring, these problems are easy. It's just like a couple of factoring problems, and the last step is just to cancel common factors. But if you're not skilled at factoring, you need to get skilled at factoring to pull this off. Now here's an interesting problem for you. Y minus 2 and 2 minus y. They are not the same thing, okay? You know, just like you subtract 7 minus 2 is 5, but you flip that around to 2 minus 7, that's negative 5. They're not the same. But that is important. Notice they're the opposite signs. So what you can do, the long version of this, is I could factor a negative 1 out of the denominator, which means I divide each of these by negative 1. So give me y minus 2. And I pull out that negative 1. That's going to leave me negative 2 plus y. Now I can rearrange this order. That's y minus 2 over negative 1, and that's the same as saying y minus 2. If I just write the y first and the minus 2 next, those cancel to give me negative 1. Now here's what I don't want you to do every time. You do not have to do that every time. Whenever you're subtracting in the opposite order, so you're subtracting and the order's backwards, okay, for one of them, you can cancel and the answer is going to be negative 1. The reason is because what we did here. You can factor a negative 1 out of the top or the bottom, it doesn't matter, to get them to match. So notice now they match, and then you could cancel, but it leaves that negative 1. The next problem uses this idea. Look at the numerator. There's a greatest common factor of 3. I'm going to pull that out. So it's 3 times y minus 9. Right? 320, yes. And in the denominator, I have a difference of squares. So remember, a difference of squares, you have 1 plus and 1 minus. Now the square root of 81 is 9. That goes in the first position. The square root of y squared is y. That goes in the second position. Now look, y minus 9 and 9 minus y. Notice their subtraction, and the order is backwards. When you do that, that's going to give you a negative 1. So I can cancel these, but that's going to leave me with a negative 1 times my answer. So I'm going to have a negative 1 times 3 is negative 3 over 9 plus y as my final answer. So it's okay to cancel these when they're opposite like that, but it's always going to leave a negative. So one more problem to wrap up this long video of simplifying rational expressions, but full of examples, right? I have a trinomial in the numerator with a leading coefficient of 1. So this is not one of those that's hard to factor. We're trying to find numbers that multiply to be negative 2 and add to be 1. And so again, just to remind you, multiply to be negative 2 and also add to be 1. Now to multiply to be a negative, you know you need a positive and a negative. And to make it add to be 1, that's going to be a plus 2 and a minus 1. So that's going to be x plus 2 times x minus 1. Why just x? Because x times x gives you x squared. In the denominator, that's a difference of squares. Because 1's a perfect square, x squared is a perfect square, and you're subtracting. That's the key things you have to have. The square root of the first term here is what goes first in your binomials. Square root of 1 is 1, 1 and 1. Now, a difference of squares is always a plus and a minus factors. The square root of x squared, which is x, goes in the second position. Now, I don't have another x plus 2 factor, but I do notice that x minus 1 and the reverse 1 minus x, they will cancel, but they leave a negative. Remember, they leave a negative or a negative 1, so that means my final answer is negative. I can leave that out front, x plus 2 over 1 plus x. Just like that. Now, if you felt like you needed to do something with the negative, you could distribute it in the numerator. That will give you negative x minus 2 over 1 plus x. Notice it doesn't go in the top and the bottom. That would be wrong. That would be like a negative over a negative, which is actually a positive. It only goes just in the numerator. And so either of these are correct answers. I hope this helps.